Hi everyone, welcome to section 4.2, Linear Approximations and Differentials. In this section, we are going to learn how to use derivatives in a very practical way. Instead of just finding slopes, we'll use derivatives to estimate function values and approximate small changes. Now, why would we want to do that? Well, sometimes a function is complicated and plugging numbers into it is hard or messy. So instead, we use something much simpler, a line. What we do is use the tangent line. This is the line that touches the curve at one point and has the same slope as the function at that point. Because a line is much easier to work with than a complicated function, we can use that line to approximate the function near that point. So, what exactly is a linear approximation? A linear approximation uses a tangent line to estimate the value of a function near a specific point. In other words, we are replacing the curve with a straight line, but only locally near that point. So when you hear linear approximation, think we are using the tangent line. So when is this useful? There are few common situations. First, when the function is hard to compute. Second, when we only need an approximate value. And third, when we are working close to a specific point. That last part is really important. This method only works well when we stay close to the point where the tangent line is taken. Here's the big idea of this section. If a function is differentiable at a point, then near that point, the function behaves very much like its tangent line. So we can say the function is approximately equal to its tangent line near that point. Now, let's write the formula for this approximation. The linear approximation, also called the linearization, is L of x equals f of a plus f prime of a times x minus a. This formula gives us the equation of the tangent line at the point x equals a. And we use this line to estimate values of the function near that point. This formula is often called two things, the linearization or the tangent line approximation. Both names mean the same thing. Now, very important idea. Linear approximation is only accurate under certain conditions. It works well when x is close to a. So if we stay close to the point where we build the tangent line, our approximation will be good. If we are close to the point, we get a good approximation. If we are far from the point, we get a poor approximation. So always remember, this is a local tool, not something that works everywhere. So to summarize, we use the tangent line to approximate a function. And this is called a linear approximation. It works best when we are close to the point. All right, that's the main idea of this page. In the next part, we'll start using this formula and look at some examples.